Hey guys, this is Shelby with the Rogers Public Library. This week for Full Steam Ahead, I want to talk to you about sugars and starches, right? So there's that's typically the words that we use for them when we're talking about food. But there's some other scientific or more scientific names for them as well, right? So one of those words is carbohydrates, right? We talk about needing carbohydrates in our diet, right? I mean that's just a big lump term for sugars and starches. And there's also a fancier word called saccharide, right? So we talk about monosaccharides and polysaccharides, and those are just it has to do more with the structure and the way that the different molecules are arranged. And includes some stuff that we don't even eat, right? And it's kind of used outside of the context of food and eating. Right, but so sugars, you're probably really familiar with this stuff, right? This is granulated sugar, right? From probably from beets, but possibly from sugarcane, right? So sugar is in a form that our cells can use really easily to create energy, right? Um, right, and there's like a complex chemical process that does this, right? But in the end, what happens is sugar gets converted into something called the adenosine triphosphate, or ATP, right? Which is just it's basically like batteries, right? It's the way that we store energy in our bodies, right? Um, Sugar molecules look a bit like this, right? This is the simplest sugar that there is. It's a molecule called glucose. Um, Although there are other sugars, right? There's things like sucrose, for instance, or lactose as well, I think, right? And you can see from looking from this, at least if you know about elemental names, why they're called carbohydrates, right? Because you have a carbon atom, you have a hydrogen atom, and an oxygen atom, right? Or a lot of hydrogen and a lot of oxygen atoms, right? So you get carbon and hydrogen or water, so carbon, hydrate, carbohydrate, right? So in contrast to sugars, starches are bigger, right? They're made up of a bunch of glucose molecules that are attached together, right? And for us to use something like flour as a source of energy, or cornmeal, or cornstarch, our bodies have to break it down into these smaller sugars, right? And so we saw how that worked a little bit last week with the experiment with iodine in the crackers, right? How our the enzymes in our saliva break down starches into sugars, right? So one of the benefits of starches over sugars is that because we have to go through this extra process of breaking down the starches, we use the energy from starches a lot more slowly than we do from sugar, right? And so starches and things like bread or cereal feel a lot more filling than just eating candy, right? Because we use up the energy from candy really, really fast because it's in a form that's really easy to use, right? Now, there's also some types of, I guess, polysaccharides that our bodies aren't super great at digesting. And one of these is a molecule called cellulose, right? So cellulose is what things like wood are made out of, right? So these are just popsicle sticks, right? And can no one know? They don't taste very good. I can eat them, and it'll just come out the other end, right? I like there are animals that can digest cellulose, right? Things like termites, uh, but not humans, right? We just don't have the enzymes to break down cellulose, and we also don't have the bacteria in our guts that would allow us to do that. But despite that, we do need cellulose in our diets, right? Not as a source of energy, but as what's called dietary fiber, right? So dietary fiber is basically just like bulk, right? Mass that gets added to the food that we eat. And we get it from things like starchy foods like bread and grains, as well as vegetables and legumes, right? So even though we don't necessarily get like a direct nutritions from it the same way that we do from carbohydrates and other things, it's still really necessary for our digestive systems, and it just keeps everything working really well, right? Yeah. So this science experiment for this week is kind of interesting. It was actually a bit of a failure, right? So I attempted to make rock candy, right? Because rock candy's fun, right? And you gotta make sugar crystals Tastes really fun, and you get to feel it kind of breaking between your teeth. So the way that you make rock candy, I mean, if you do this, you'll want a grown-up's help because you do have to use a stove, and it gets really hot. Is you basically put a bunch of sugar in water, and you boil it until the solution becomes super saturated, right? So the same thing that you would do with like if you're growing borax crystals or something. And then right, and so once it's super saturated, there are way too many sugar molecules in the water, and they will come out of the solution as the water cools down. Right, they'll precipitate and form rock candy. So I attempted this and it did not work. Right, I just didn't have any crystals form. Instead, what I got is syrup. Right, pink lemonade flavored syrup, to be specific, right? And that's pretty cool because syrup is interesting for different reasons, right? It's what's called a hypotonic solution. And what that means is that there's a lot of dissolved stuff in here and very little water. And hypotonic solutions are really good. They're antibacterial basically, right? It's just like people and animals need water to for our bodies to work. Bacteria also need water to perform their cellular functions, right? You can't break down sugar and make it into energy without water, right? That's another key ingredient. Right? And so bacteria have a hard time in growing in really concentrated solutions like syrup, like this syrup, or like corn syrup, or like honey or maple syrup, right? So it's interesting. Yeah, it's good. I mean, it tastes like syrup. Tastes like pink lemonade, basically. Yeah, this is also why candy doesn't really go bad, or that why candy lasts for so long, right? Is because there's not a lot of water. It's a lot of sugar, and so there's no bacteria just can't grow in that environment. I'll set this aside, and then I'll talk to you guys about our craft for this week. Right. So this is a little lollipop that I made. Right. It is a wooden circle plus I guess my candy making supply, right? It's a little stick. Right, and I just drew on it and I made it look cool. I already touched the stick because it's kind of a hit or miss process. I wanted to do that before I started filming, right? And I'm gonna do this one a little different. I'm gonna glue a circle onto it because I think it'll look nicer compared to the other one where I just drew directly on the cardboard. Right, my markers will show up a little bit better on the construction paper compared to the cardboard. I'm gonna get my markers, and I think this is a cool color. Right, it's an aquamarine. Seafoam green is the color name. So I'm just gonna draw on it. And maybe I'll get some purple too. I think that would look nice. I'm going to do this light purple. It's a lavender. It's tropical violet is what it's called. And it actually shows up pretty dark on the page. Even though the color of the marker is light. Great. Okay. So here's our lollipop. It is bubblegum and green tea and grape flavored is what I decided, right? This one is just cotton candy flavored. Yeah, but we'll have craft kits for you guys to pick up here at the library. And that's what I have for you guys this week. I hope you had fun and you learned something, and I'll see you next time.